So, good afternoon, everybody, and welcome to my talk on refactoring. I want to show you how to make your IDE do your work for you and for it to do it faster and more safely. I'm Clare Macrae. I've been programming in C++ for more than 20 years and Qt as well, and programming for a living for a lot longer than that. My background is chemistry, and I've done a lot of work on crystal structure visualization software. In recent years, I've been focusing on help people test code more easily, especially legacy code and hard to test code. And I'm the co-author of the Approval Tests C++ library. And you can get in touch with me via my email address, which is there on the screen. And my Twitter handle is on most of the slides as well. In terms of questions for today, rather than having questions during Zoom, we're going to leave questions until Gather Town at the end. So I will go to the Q&A rooms via the entry on the top of this picture at the end of the talk. And I'll be in the Q&A section on the right for the B track. In the meantime, if you think of any questions and you want to make a note of them, feel free to drop them in the track discussion channel in Discord. That's an optional extra. So I hope to see some of you there at the end. So I have three goals for today's talk. I want to inspire you to explore your refactoring tools and your IDEs and to experiment with them. So not just know what's there, but actually try them out and use them enough and practice them enough so that they're automatic and you can know the change that you want to make, and just it's in your muscle memory to know how to do that automatically. So what do we mean by refactoring? It's a commonly used term. My favourite definition is it's improving the design of existing code. And that's really important. It's about changing the design. It's about restructuring code, but keeping the behaviour the same. It's not about fixing bugs, and it's not about adding features. But by restructuring the code, you can make it easier the purpose is to make it easier to fix bugs and more commonly to make it easier to add new features. So, wow, this is advancing somehow rather more quickly than I expected. So the idea behind it is you make a micro refactoring, a small change, and you review that change, you run your tests, and then you commit the change and carry on. But let's look at that a bit more closely. When you review the change, the question you're asking is, have I improved the code? Has this got better at all? And if it has, you commit. You move on to the next step, but crucially, if not, you revert the change. So more often than not, you don't try and fix it manually, you try to do the refactoring in a different way. And of course, if you run the tests and they fail, you would do the same thing, you would revert. And if tests pass, you go on and commit. So I mentioned in the title of the talk that this is about safety, but where does that safety come from? Well, the first place it comes from is your IDE and its knowledge about the language that you're using, about its little hints that it gives you, little warnings about issues you might fix in the code. It'll be running the compiler for you as well, of course. And so the compiler gives you feedback. You get safety from your tests. Usually, hopefully, these are automated. Sometimes, if it's not tested yet, you might be running the software manually until you've made enough changes that you can actually add tests. And then through version control. Now, I and others recommend when you're doing automated refactorings to commit little and often. And the safety that you get there is if you find you've gone down a dead end, you can go several stages back in the version control and try a different route. So you're never losing the work you've done. Or maybe if you do unintentionally introduce a bug, you can use get bisect to narrow down the change that caused the error. There's a separate conversation to have about whether to squash the commits later on if you need to. And I think that's an organizational policy and it's a kind of a personal preference thing. So it's entirely up to you. But the point is, as you're doing these changes, do try and commit little and often, and it will save you time in the long run. Now, here is one of my favourite quotes about refactoring or supporting refactoring. It's from Kent Beck. For each desired change, make the change easy, warning this may be hard, and then make the easy change. So what that means is if you go to implement a feature or fix a bug and you find that, or particularly with new features, maybe you're doing something that the code wasn't actually designed to do in the first place, don't try and shoehorn it in and make the code harder to maintain. Look at what you need to do to improve the design of the existing code so that it becomes easy to make the change. And that always pays off in the long run, and it usually pays off in the short run as well. No talk on refactoring would be complete without mentioning Martin Fowler's book, Refactoring, and this is the second edition that came out in the last year or two. It's a really well-structured, informative, well-written book. It talks about smells in code, the kind of things that, kind of problems that you might find in code that you're modifying. Perhaps super long methods, relying too much on low-level primitives like ints and strings instead of having behaviour encapsulated. And then for each of those smells, it recommends particular refactorings or series of refactorings to use. So it's a great way to be learning how to apply refactoring. There's also a free website, refactoring.com, which is an online catalogue of refactorings from the book and some others as well. If you're not logged into that website, if you don't have a license for the web edition of the refactoring book, then the catalogue has just minimal pictures. But I recommend I use the web edition in conjunction with the catalogue because it has the full text, but the navigation around is really powerful. So for a talk on refactoring, we need to have some code to work on, to try out. And I've picked the area of Sudoku. Now, if you haven't seen it, Sudoku is a maths puzzle. So you get given a grid of 9 by 9 numbers, and some of the numbers are missing. So these are the blank cells here, the blank squares. And the idea is that you use the rules of the puzzle to fill in the blanks, to fill in the gaps. And the rules are that each row needs to have each digit from 1 to 9, each column needs to have each digit from 1 to 9, and each little block of 3 by 3 the same. And so I started off preparing for an earlier talk on refactoring using the code, having enjoyed this JetBrains webinar by Zoran Horvat, refactoring a 1,000-line method into cleaner code. It's really interesting. He did it entirely by, pretty much manually and by using the compiler for feedback. And I wanted to see how far I could get by using automated refactorings. And the code he used, his repository, Sudoku Kata, coding practice demonstrating an awfully long method, and it's in C#. And you might be thinking, but hang on a minute, this is a C++ conference. And indeed, that would be true. So that earlier talk was my talk at ACCU earlier in 2021. And for that, I was entirely using C# code. I was a novice in C# and I was a novice in the tools. And I was amazed at how far I got with the really powerful refactoring tools in C#. And I got some really valuable feedback via the conference from attendees of the talk. Things like leveraging the IDE to do more of the grunt work is something I'll be experimenting with. So yeah, that's great. That makes it all worthwhile. But another thing was the C# tooling is much better than the C++ tooling. And that was definitely my experience in working on that talk. So I started to wonder, well, how far can I push the C++ refactoring tools? And is there a C++ talk there? But then the last of the feedback I got was, as a C++ programmer, her mostly C# talk did nothing for me. So on reflection, I decided that was actually really useful feedback, because my intention is that these talks are applicable across multiple languages, whatever the examples are in. So it told me that I hadn't made that clear. So now I'm wanting to make that clear to you. You will find if you're using Python IDEs, C#, if you choose a good IDE, you'll have all of these tools available. But that really cemented the idea that I had to try a C++ version. And so that meant converting the C# code to C++. So first of all, I tried to do it manually, and I got about a fifth of the way through. I used the tests that I had created on the C# code and used the same tests, the same outputs from the C# version, and made sure I could reproduce them in the C++ version. So that was great. I got tests pretty much for free. And so I knew that the behavior was wrong. And so I gave up eventually trying to work out what the problem was. I couldn't see it. And so then I tried out some free C++, C# to C++ conversion software, the free edition of the software. It's created by a company called Tangible. And converting 100 lines at a time, it was clear that it was going to take a long time, but it was good enough that it was going to save me time. So I stumped up the $150 for a 1-year license for this tool. So after a year, it will revert back to the free version. And they are really clear in their documentation that the conversion tool gives you a starting point and does a lot of the basics, but you will have to do a lot of manual fixing. And sure enough, I did. But that ended up giving me 1,200 lines of C++ with passing tests. And so I've created a new repo. I'll have a link at the end where you can get all of the links to all of the code and tools I mentioned and things like that. So I was quite happy about that. One slightly ironic point to mention is when I finally got all of the auto-generated C++ code compiling, I had exactly the same bug as in my manual conversion. So that was somewhat ironic. And maybe there's a talk in there about all the things I learned about conversion between languages along the way. So, of course, the next thing I'm going to do, okay, so I should say at this point I had converted the implementation, the Sudoku code, and now I was going through the whole process again of, imagine I was starting with just the implementation code, and now I need to modify it to add tests. So the first thing you do when you have no tests is run the software and see if you can find a way to understand what it does. And in this particular case, it's a console program, and it generates, it writes out a full Sudoku board, so all 81 digits populated, and then it removes a load of digits to create a puzzle. And then it goes through, so the third step that it does is try to solve the puzzle, and it does that one step at a time. And it writes out the grid of digits, and then that bottom line, that's an 81 character string, which it calls a code. And that turned out to be useful later on. So there are two different ways of seeing the state of the board. And 776 lines later, that was the end of its output. Okay, so obviously something which generates text is really amenable for testing. And in order to do that, I ended up trying this out in CLion, the JetBrains tool, and using extract parameter. So I want to explain how extract parameter was useful for adding tests. So this was what the original code looked like. There's a play method, and it creates a random number generator object, and it creates a console object. And it turns out that I needed access to both of those for the tests. So I started off by extracting random number generator to a parameter, and it wanted me to confirm the type and to confirm the parameter name. So I did that, and I actually did the same for so that was my output after the first step. And then, so I got my random number generator parameter, and it updates all the calling code as well. But an interesting thing was where this function was being called, it didn't know how to create an object to pass in. Now that surprised me because I thought it probably could have worked out from the code that I was extracting, but given that it didn't, I really like the fact that it created something which didn't compile. And I think with refactoring tools, that's the best mode of failure. The alternative is it creates something that perhaps fails at runtime, like throws an exception, or even worse, it's empty and it doesn't generate an error. So you want to make sure you are prompted to fix anything that needs fixing. ReSharper C++ and Visual Assist, as of a few weeks ago, didn't have an extract parameter refactoring. So I did a lot of comparison between the different tools of what features they had. And there was no one tool that had everything that I wanted and all of the options that I wanted. So with a second extract parameter step to get access to the console, I ended up with my program play method looking like this. So I'd got my console parameter, and that allowed me to get the written text, the output text out, and use that as part of my tests. And I needed to be able to control the seed of the random number generator, because it turns out that if you run this program repeatedly, it gives different output each time, which makes sense. It would be kind of uninteresting if it always gave you the same board. And then I used an approach called approval tests to capture the output. So my test is called should do the same thing twice. And I create a console object. And I decided, so first of all, I ran program play once with a random number generator seed of 0. And that was great. I got to 90% coverage with that. But by adding this loop and trying out 10 different seeds in succession and writing them all out to the same stood string stream, I then got to 100% coverage. And I passed the output string into approval test verify method. And that worked really well. This talk isn't about approval tests though. So if it's new to you, then this talk, my talk from CppCon nearly 2 years ago, gives a broad introduction to it and a lot more information. Just to let you know, though, that approval test for C++ works with 6 different commonly used C++ test frameworks. Although I just showed you an example in Catch, it works as a layer on top of multiple other test frameworks as well. Right, so moving on, a thing to say that there is really a common pitfall in refactoring, which is to keep fiddling, keep improving the code, keep dividing code up and moving it around, and get to the point when you're probably not actually making any further improvements. And you end up with this sort of bottomless pit of refactoring doom. So the way to avoid that is to know the purpose of the change that you're making. So might be fixing a bug, more likely it will be adding a new feature. And that applies to talks as well. So for today's goal, I want to try and modify this code to see if I can use it to solve puzzles set by others. So let's set out to try and do that. But first, let's have a look at the code. So big health warning, don't be tempted to read this code. This is what the original C# looked like. So that's 10 lots of 100 lines, so 1,000 lines of code, almost all of which was the solution code, the generation and solution code. By the time I've converted it to C++, it was 1,200 lines. So what do you do with long code? Divide and conquer. Start extracting methods out. And I started off trying this refactoring out in ReSharper C++. And I was able to tell from the comments in the code, the detail of this doesn't matter, but from the comments in the code at line 200 and something was the start of the solving code, and down to line 120 or thereabouts was the end of the solving code. So I knew that that was the code that I wanted to be able to call separately. So I selected all of that code, obviously collapsing the regions down, these little pluses here, that was really important, collapsing the blocks of code down to be able to select it. And then I right-clicked and chose refactor this, and up popped an option with all the different things I could do on that block of code. And I said extract method. It might say extract function, but they all do the same thing basically. And this dialog pops up. And the crucial thing to tell you here is that in terms of ReSharper, in the blink of an eye, it has analyzed that 900 lines of code and it said, okay, these are the parameters, these are the things that were declared before the block of code that you're trying to extract. So these are the things that have already been created and probably populated, and we're going to need to pass those in to the new function or the new method that we're creating. And a thing I really want to try and stress here is lots of people think, well, you know, what's the big deal? I can divide this code up by hand. Maybe I get rusty if I let the tool do it for me. But I don't think there's any advantage to you in having to work out by hand, by reading through the code, by reasoning about it, when a bunch of people have been working on these tools for a bunch of time and they've programmed the logic for you. So remember back earlier on, I had this loop and I said that you do a refactoring and then you ask if it's an improvement. Well, dividing this up would be a bit of an improvement, but that's quite a lot of parameters to pass in. And so I'm not really sure that I want that many. I mean, I could go ahead and do the refactoring and then remove the parameters later on. But it can be easier to make small changes to the code that you're extracting and reduce the number of arguments, the number of parameters. So quick things to point out, ReSharper offers an initial name of do work. And then here are the parameters. And in fact, I decided I was going to cancel and see if I could try it a different way. So then the first thing I tried, when I looked at the parameters that it was creating, there was a whole bunch of them that were called stack something or other. And where they were used in the code that I was extracting out, there was this comment that said, well, we duplicated a whole load of code that was earlier because we couldn't quite reuse it. And it turned out it was reusing the storage as well. So that's what all of these stack things are. And so I wanted to use the IDE to do an experiment for me to see if it was safe to create an independent copy of those stack containers and the command as well. So the first thing I did was to take the block of code that used these containers and surround it in curly braces, so to create an extra scope. Well, of course, the code is going to compile there, and it did. But I ran the test just to check. And that's what this difference looked like. So it did the nice thing of adding the parentheses and indenting the curly braces and indenting the code. So yeah, okay, maybe it's no big deal at doing it for you, but I didn't even have to think about it. It was just a couple of clicks to get it to do it for me automatically. And I'm keeping my concentration then. I'm not having to think about the mechanics. I can always think about what the next step is that I want to do. And then, because the test passed from that, what I then did was, so again, several of these slides, I'm showing you the difference. And so on the left-hand side, there's the code before I made the change that I'm talking about. And on the right-hand side is the code after I've made the change that I'm talking about. And the highlighting is a bit weird here, but the change is that instead of resetting the contents of each of the containers, I'm now creating new containers. And of course, they're empty by default when they're created. And the code tested, the code compiled, the test ran, and the test passed. So that's great. That tells me that, so that helps move me on to the next step. Some of you might be noticing, though, that I've now got variables that are shadowed, and I might get a shadow warning, a warning that I've got variables in this scope that have the same name as variables in the parent scope. And if I've got my build environment set up to treat warnings as errors, this would actually fail. And in that situation, I think I would have proceeded with the original 10 or so parameter refactoring, and then rework the code to remove the unnecessary parameters later on. So either approach is valid. Okay, so great, let's move on then. So I had that original problem that when I extracted the code, there were too many parameters. And so now I've changed the code, so it should be easier to refactor. So let's repeat this. And this time I'm going to try it out in 3 different refactoring tools. 2 of them, ReSharper C++ and Visual Assist, are Visual Studio add-ins, extensions. So they're only any use if you're running on Windows, whereas the CLion, the one in the middle, that runs on Windows, Linux, and Mac. So I repeated the setup for extract method, and the only difference was I'd got these extra stack variables. And I asked ReSharper to extract the method, and it was great. It was really successful. I had the result that I wanted. So it told me that I needed to pass in the random number generator and the console. Well, those were parameters I'd already extracted. So of course they need to be passed in, and I'm happy about that. But the other thing that it told me now was there are only these 3 things that I needed to pass in. And it turns out that that is what represents the puzzle that we need to solve. So board, state, and final state. So I still don't know anything about what they do, but I've learned something about the code. I've learned that those are the things that matter in the earlier 250 or 300 lines of code. Now, it's interesting here that the code that ReSharper creates, it's passing those things in by value rather than by reference. So that actually is potentially a subtle change in behavior. However, I'm extracting to the end of the method, so it's possible that it knows that no other code later on is going to be referencing the modified data. I don't know if it's being clever with that or not, but that's definitely something to look out for, is whether things are passed in by reference or not. So this was what the change in the header looked like. So these lines in green, these were the new lines that were added. So it added the include files that I needed, and it added the declaration. And then in my CPP file, it looked like I'd got 700 or 800 lines of changes. And that's because it extracted the method out, which was towards the end of my file, the code I extracted, it put above. So it looked like it was quite a complicated change, but it compiled, it ran, the tests all passed. So that's, big success with ReSharper C++. Then I tried the same thing in CLion, and it said, these are the parameters to pass in, and it came to the same conclusions as ReSharper C++. Well, they're created by the same company, so maybe that's not too surprising. But interestingly, CLion did put the references in on the last 3 parameters. This is on Windows, and CLion on Windows, selecting those 900 lines of code or so, it took at least 10 seconds of thinking for this dialog to pop up, whereas ReSharper C++, it popped up instantly. I mostly develop on Mac, and it's a known problem with the refactoring tools in CLion or Mac that many of them are significantly slower than they are on Windows. And so there's no way I would try this refactoring currently on CLion on a Mac. But I do know that JetBrains is working hard on improving that, and I'm sure it will get better. But yeah, 10 seconds, small price to pay for the amount of brain effort that we've saved by doing this. Another small difference is that CLion doesn't put in a default name, so it makes you think about the name. If you aren't sure, you can call it applesauce or do stuff and improve it later. But otherwise, basically the same. Now let's look at the changes that CLion makes. So in the header, rather bizarrely, it's changed std ostream to std basic ostream, which is correct, but it does make the code less clear. Worse than that, with the std vector of char, it's completely mangled that to something that won't compile. On the C++ side of the CPP file, the code isn't compiling. So here's the first error, and that's caused because of the mangling in the declaration. But it did get the stream right, and it did get the vector right. And so I was able to copy those 2 lines back to the header file. And the thing that I really liked was it left the code it was extracting in the original location. So these lines in green on the right-hand side are the only changes to the file. So in our version control history, that's a nice clean change. Bizarrely, it deleted a line ending there. I don't know why, but that was trivial to fix. So when I fixed the declaration, then the code compiled, it built, and the tests passed. So that's sort of almost there with CLion. And then the third tool I tried was Visual Assist, which I think is less well known than the JetBrains tools. I used it very heavily some years ago, and even then it was really powerful. But unfortunately, in this particular case, it said, computer says no, cannot extract method from selected text, and nothing I tried could make it actually extract the method. And I do want to say at this point that although Visual Assist failed here, it has plenty of other refactoring capabilities that CLion and ReSharper C++ don't have. It has tools that are unique to it. And in some tools, it has much better, more flexibility, and so it gives you more control. All 3 of them, I think, have an encapsulate field option, and they'd add the setter and the getter if that's what you want. But Visual Assist also has the ability to update all of the calling codes. So everywhere where the field is used, change it to the new setter or the getter. And that's really, really useful. So I do realize that I am very unusual in having 3 commercial tools here because I do a lot of this sort of thing. It's my main focus, and so I've chosen to spend the money. My message here to you is use the tool that you have. I'm showing the kinds of capabilities that they have. I'm not saying go out and buy all 3, but try out the tool that you have. And if it doesn't do what you want, by all means, try evaluations of the other tools. Oh, and other refactoring tools and IDEs are available as well. So, but in this particular case, that was sadly not working. So let's look a bit more closely at ReSharper C++ and CLion and what they offered for extract method. So basically, they offered similar capabilities with subtle differences in how you did things like reorder the parameters if you wanted to. But basically, they came up with pretty much the same code that they extracted, apart from these references that I think CLion was correct to add. So there we are. But what if you didn't have one of these refactoring tools? What other options do you have? Well, a lot of these things, once you've learnt the techniques, it is possible to do them manually and safely. And I want to let you, just for awareness, know about a GitHub repo called Provable Refactorings. And it's basically a collection of recipes, lists of steps in Markdown. And steps are only documented there if the authors are confident that the compiler will tell you whether the step worked or not. So they don't depend on you having test coverage for the code. So that can be really powerful. So as an example, there's a recipes core 6 extract function, and the description in C for how to do this in C++ has 9 tiny steps, of which the final step is optional. So the first step is surround your code by a lambda and invoke it immediately. So I tried this out on the same body of code, with someone, Llewellyn Falco, talking me through doing each of the steps on the 900 or so lines of code that we just talked through, refactoring automatically. And I'm not sure, it probably took 5 or 10 minutes of talking through and explaining it. I think if I practiced it regularly, I could get down to maybe 3 or 4 minutes or something like that of going through each step. I would automate some of them, so put something in to make it quick and easy to correct the lambda. And this would be an unusually long amount of time because of the number of parameters that I needed to generate the code for. But it is a powerful technique, and it's a good thing to fall back on if you're working somewhere that you just don't have these IDEs available. Having gone through this and a lot of other experimenting with refactoring in C++ IDEs, I want to give you a kind of checklist. And this is something that now I review as I'm refactoring. So think about whether references needed to be added or not in new parameters and return values for that matter. Think about whether new methods wanted to be public, protected, or private. So the C# IDEs ask you before you do the extraction, what access do you want? Whereas you don't seem to have that control up front in the tools I've been trying out here. Should the parameter be const? Hopefully, so I was extracting from static methods, and so there wasn't any possibility to make the methods const. But have a look and see if there's any more ways you can add const. Do you like the order of the methods of the fields that have been extracted? Can you add no discard? Is there any clutter that you need to get rid of? So, for example, CLion, when it's extracting STL types, it sometimes inserts this __1::: that didn't exist before. And I don't know why. So at some point I should probably write some quick fix in CLion to make it just find and replace and get rid of all of those. So I'm always looking for ways to save time, get the tool to do work for me. And I want to say I'm not trying to undermine these tools. And by the time you watch this talk on YouTube in future, it's entirely possible that some of the things I'm pointing out are fixed. I'm trying to give you a realistic view of the current state in mid-2021 of refactoring tools in C++, and trying to let you know that they're still valuable, but just be aware of for the tool that you're using, any fixes you may need to apply. Okay, so I mentioned that there were these three parameters that were passed around board state and final state. And I decided to encapsulate those in a class called grid. And I use the word encapsulate loosely because you can see they're all public fields for now. But I changed the code to pass those around. And it's a common thing in legacy code and code without tests to find that although the concepts of a grid and a row and a column in this case, they have to be represented in the code because the code was doing things to create Sudoku boards and manage them. But those concepts are not represented in the code. It's entirely working with ints and strings and characters and vectors of those and vectors of those. And that's a smell known as primitive obsession. And so this kind of idea of extracting data into fields and then the fields into classes and then starting to give the classes behavior and then eventually making the data private, those are all steps that are things that you can practice and learn to do and will help you learn about the code and improve its design and make it more maintainable. It turned out that board vector, the first vector, contained the same data as the state. One was an integer representation and one was the string representation. And so I ended up writing some helper function, somewhat imaginatively named grid stringifier, convert to string, that created the string representation from the integers. That meant I could get rid of the board field altogether, and that left me with a whole load of unused code, which the IDEs warned me about and allowed me to quick fix and delete the unused code. So that was really good. And then I added to code and to string methods to hide the grid stringifier class. So that worked well. So now we come back to the original goal: for each desired change, make the change easy, then make the easy change. But it turns out that those few things that I've done were enough to be able to come up with an easy implementation. So I started by writing my test. I got a Sudoku puzzle board from somewhere on the internet, and then I took its string representation, its code representation, and fed it into another website that solved the board for me. So I've got my input where the zeros represent unknown digits, and I've got my expected, which is the solved board. And that second website told me there was a unique solution for this puzzle. And that turns out to be important for this code. This code doesn't generate puzzles with unique solutions, and its solving code is therefore much harder. It's kind of doing extra work to try and find the original solution. But anyway, my test became create a grid solve method that takes the input string, returns a modified grid object, and converts it to code, basically. And that, of course, didn't compile because the methods didn't exist yet. What I ended up creating was this grid constructor, which takes a string and loops over each character. I put in an assert on the string length for now. In production code, of course, I'd do something nicer, but this was just a precaution for my test to get me going. And that final state container, because I know that I'm dealing with a unique solution, that final state container isn't used. So that was really easy. And then my solve method, it takes the code, the 81 character string, and I create a string stream to capture the logging, which I'm going to ignore, and a random number generator. I don't care, I don't need to give it a seed. And create the grid object, call program solve puzzle, and return the solved grid. That's it. So I have to say it turned out to be a lot easier to extract that huge amount of code than I expected. It won't always be that easy, but you will always make progress and you will always improve the code as you go, because as you divide up long methods, reasoning about them in future becomes easier. So even if you try refactoring, you try along the way and you don't actually get to the final solution, the return on investment of improving the code as you go, it really pays back quickly. Let's talk a little bit more about adding abstractions. So my other favorite Kent Beck quote that's useful for refactoring is, if you're ever stuck wondering what to clean up, move similar things closer together, similar elements closer together, and different elements further apart. So let's think about a class that has lots and lots of methods. What might that mean? Well, when we talk about removing related things closer together, that might mean finding methods that have the similar names. So maybe you've got a load of methods that refer to, I don't know, we might have some methods that refer to a row and some methods that refer to a column. There's a concept in this code of finding candidates. So for a given digit that hasn't been solved, what are the remaining digits that could go in there? So we might divide up some of that code and end up moving related things closer together and removing unrelated things further apart. And so if I had further features to implement for this on this code, then I would be looking at finding the concept, dividing the code up, and starting so that you can express the code in terms of grid dot set digit at 1, 1 to be number 8 or something like that. So starting to make the code talk about the objects, the types and the concepts rather than the ints and the strings and so on. As a few tips in terms of refactoring, it really matters when you're extracting methods and functions and data, whether the thing that you're dealing with is static or not. So you can take static, you can sometimes get a better result in refactoring code in classes by either making static methods not static or adding a non-static overload and having the static one call the non-static one, or vice versa. So you don't have to be stuck with the structure that you've got. And you can move methods as well within IDEs. So you can move them to different classes, to different files, and you can use them to, you can experiment with, if you want to move it to a different file, don't bother creating the file manually. See if its move dialog will allow you to type in a new file name and if it will move it automatically. Okay, so that you will get a lot from the refactoring tools built into your IDE. But it turns out that there are a lot of similar kinds of capabilities in these IDEs that will help you with refactoring, but they're not labeled as refactoring tools, and it's really easy to miss them. So let's keep exploring what the IDE can do. I sometimes find with refactoring that I go to do a step that I know is valid and the IDE doesn't offer me that option. And it turns out that it's really important where your cursor is in the code. So make sure when you are, make sure that if there's a red squiggle, that, I don't know, header missing or something like that, and you want to get it to fix that, click in the error message, and then you'll get the option. If you want to rename a variable, you probably don't want to click on the variable's type, you want to click on the variable's name, and then you'll be able to refactor, then the refactoring will be available. There are many ways to find the refactoring capabilities. They might be in the main menu, they might be in the extensions menu, you might right-click and say refactoring, or my personal favourite is to find the refactor this option, which can be a single shortcut to memorise, and then it will show you the options that are only relevant for the context that you're in. There are also things called quick fixes, which I'm going to tell you a little bit more about, and the idea of generating code as well. And I regard them as essentially refactorings. Well, I suppose they're not changing the behaviour, but they're automations that help on the way to refactoring. So the first thing is you'll probably find your IDE has got mechanisms for generating common patterns of code. Create constructor, destructor, getters and setters and so on, relational operators. If you're inheriting an abstract-based class, it will have the ability to override, to implement all of the pure virtual functions in the base class, for example. And so this is really, really powerful. We'll probably also have a surround with type capability. So you can select some code and surround it with an if block or an if else or a while or a do while or a for and so on, all these really powerful things. And notice the live template section at the bottom of that menu. That's really, really useful. So if you find that you're repeatedly surrounding code with the same kind of pattern, then teach your IDE to do that for you. Now, the opposite of surround with is unwrap. And I only discovered this in preparing for this series of talks. So I've right-clicked on some code, I've selected some code which is nested, heavily nested inside whiles, ifs, whiles, braces, whiles, fors, and so on. And as I move the cursor up and down that list of scopes, the selection behind the highlighted text changes. But I want to give you a concrete example of that because it's quite hard to visualize. So on the left-hand side, I had a for loop. And let's imagine that I wanted to change that in some way. For whatever reason, as some step, I wanted to get rid of the for loop. So I selected that code and I said unwrap and unwrap the for loop. Now, you might think that it's going to create 10 instances of the code because the loop had 10 values, but it doesn't do that. It creates the integer variable for the loop counter and sets it to the first version. And then it's up to me to decide what to do with the code next. So it's another thing where you don't have to think about delete 3 lines, navigate around, reformat the code. It just does it in one step. The other thing that's really super powerful is intentions, quick fixes, helps. And these will vary from tool to tool. And this is a screenshot from the options. I'm not sure if it was in CLion or ReSharper C++. So it's in the settings, and I can say which options I want to have, which of these quick fixes I want turned on or off. I don't know why I would ever turn any of them off. So, for example, you might have some code which says, if not A, do something. And you can you have two different ways of controlling that. You can get it to negate the if and keep the logic the same. So if you've got an if and an else, you can switch the two round and it will get the logic right. If you've got nested ifs, it can combine them together into a single if with multiple conditions, all sorts of things like that. It's really, really lovely. As an example of that, one that got added recently to CLion is this for intention. And I think this has been available in other languages for a while, because when JetBrains tweeted about this, I saw a bunch of C++ developers saying, oh, I'm so glad I've wanted this for ages. So you've got a container. This happens to be a parameter called board. And I want to iterate over the values in the container, and I don't want to have to type the code. So there's this convention in JetBrains IDEs, and for all I know, other IDEs as well, that if you type container.for, it will gives you the ability to easily create the code. So it's shown in red because Vector doesn't have a for method, but this help thing pops up, this quick fix pops up. And in this particular case, it offers me two choices. I can hit the tab key or press enter to generate a const, iterate over const references to the elements in the board, the values in the board. Or if I hit the down arrow or typed FORMUT, it would give me a mutating loop. Having got used to that really quickly, it's really hard now to be in IDEs which don't have that capability. So these are more examples of where you can be programming at the level of intention. You can be thinking about what you want to do and just knowing how to do it. And whilst the IDE is doing that, you're knowing what the next step is going to be, rather than you having to write out the mechanics. Now, I've said multiple times through this talk, your IDE, but it's more than your IDE. It's the language that you're using. The languages differ very much in their capabilities and how amenable they are to automated refactoring. I've heard many people say that C++ is much harder to refactor automatically than many other languages. Maybe that's a part of the reason why we have fewer capabilities here. But development tools differ, so it's worth spending a little bit of time each day exploring new extra capabilities of your IDE. So experiment. Okay, so let's move on to the last section of the talk. So although I've been showing you really specific examples here, and particularly gnarly code, I want to be clear that there are much more general benefits of refactoring. For example, you can be confident that the behaviour of the code is unchanged. And what does that mean? In practice, that means you're going to be spending less time debugging and bug fixing changes that you accidentally introduced if you made the changes by hand. As you're going through these refactoring steps, you're making the code a little bit better each time, at each step. And that might be better for your future self. It might be better for future colleagues. But every little improvement helps. Your users will almost certainly get the feature sooner because you'll be making the code easier to maintain. And they will definitely be getting future features sooner. And you'll be less tired at the end of the day because the IDE has been doing a lot of work for you. So reminder about safety, you're getting it from the IDE, you're getting it from your tests, and you're getting it from version control. And remember to commit little and often. So my message to you is explore. Explore the refactoring capabilities, the auto fixes, all of those things. But also a particular plea to the C++ developers amongst you. Please, if you find bugs in these capabilities in your tools, please report the bugs to the vendors. Or if you go to report it and you find that the bug has been reported already, then please upvote existing bugs. And please request missing features. I've seen, for some of these tools, 5-year-old bug reports about really fundamental features that have got very few votes. And so it's understandable if the vendors concentrate on implementing other things instead. But these things are really worthwhile improving. Practice refactoring difficult code. There are lots and lots of katas out there, practice exercises, and know how to use safe steps to transform your code, and you'll transform your working experience as well. So thank you very much indeed. I'll stop there. I'm always happy to answer questions about these sorts of things. I'm happy to be contacted on the #include Discord, include C++ Discord site. My Twitter handle and email addresses are there. And I will post this link later, but that bit.ly link to refactoring-superpowers takes you to a markdown page on my GitHub Talks repo, where there are links to the code, the C++ and C# code, and lots of the tools and techniques that I've mentioned. So with that, I'll stop there, and hopefully I'll see some of you in the Q&A section of GatherTown in a few minutes. Thank you very much indeed, and bye-bye for now.